All right, so that was for the resistors. And similarly for transistors and all these things. So again, calling these MSB, it makes it awkward. So I would probably call these maybe VMSB and VMSB bar or something like that. And that would be much easier. So I can see that here, Yikun has copied VB and this dot from the symbols file, and that's great. Because as you can see, we have, okay, let me adjust this here. We can see that we have nice spacing between these two, between all these three, so it's very easy to use. When using flow of current, use a thin arrow, not a thick arrow, unless there are some occasions. Sometimes you even use a color for this arrow if we want to emphasize the flow of the current. Okay, so here, if we have a node in the tail, it's probably better to call it by letter rather than a voltage, and then we can always refer to that node voltage. So we might call this just node P, in which case it would be uppercase, or maybe this one node Q, or M. Well, we wouldn't call it M because this transistor would be called M1, so there's confusion, right? So it would be P, Q, or A and B, or something like that. Okay, again, all the equations that you write here have to be bold. If you are making a formal presentation, these equations don't look good, right? I mean, compare this with an equation in a paper. So the way I would do these, if I really have a formal presentation, is that if the equations are extensive, for one of the equations, okay, but if the equations are extensive, what I would do is I would actually type these in LaTeX, run LaTeX, and then convert to PDF, copy from PDF, and bring it over here, okay? But if you're doing it here, just for like one little equation, the least you can do is make these italic, because these are mathematical quantities. Mathematical quantities should be italicized. Similarly, this V, right? This should be italicized. This V, this I, this R, this I, this I, this I, all of those should be italicized, okay? So that's what we do. All right, moving on. So here we have a similar situation. So again, these have to be bold. I presume this means proportional to, but of course proportional to is not something you can find on the keyboard. So Yikun decided to use this tilde, right? But that's not the way to do it. So you have to find the proportional sign. Where do you find it? Either you go to somewhere in PowerPoint and find it, or you can draw. Actually, we have that in the symbols file. You just convert PDF, copy and paste, and bring it over here. Or it might be easier just to write this whole thing in iDraw and then bring it over, right? Rather than try to do it here in PowerPoint. So proportional sign is like this, and it should be properly introduced. One other thing I noticed is that for some of you guys, the slide number is something, apparently there are two numbers. One is buried under this, and one is showing on top. I'm not sure how that happened and how you guys did this, but again, it should be something only in the master. This is not something you should do by hand. By hand, add a slide number every time you add a slide, okay? It should be all automated. So I don't want to see that there is some object here that I can edit. I should not be able to edit this, right, on the regular slide. This should be only in the master slide, a number that automatically changes. Okay. One other thing you notice is that we have a lot of space up here. And what this does is it constrains whatever we want to put here. So there's no reason. In the master slide, you can reduce the space by at least a factor of 2, this much, right? And then everything comes up, and that gives you more space. In a PowerPoint slide, typically the vertical dimension is the bottleneck, not the horizontal dimension, right? So we want to maximize this vertical dimension. And here's a situation where we are covering the logo anyway, so I might just well just have not have the logo in all of the slides, but the master slide. Okay, so again, a circuit at transistor level. So here, if you look carefully, you see that V in 2 is running almost into that dot. So what we should do is you just click on into in iDraw, and then you hit return. When you hit return, it gives you the option to move it. It says enter the x and y that you want to move by, and you move it to the left by a negative number, like -1 point or maybe -2 points. And that's enough because the spacing between these two is too much anyway, so this will move this way by 1 point and it's no longer that close to that dot. These are all little details that determine whether you're professional in your presentations or not. Okay? All right. So again, select and select bar in this case is okay because yeah, this is a more logical command than an actual voltage, so I would probably keep that. That's all right. This Y is a little too close to this line, so again, I would want this Y to go to the left maybe by 1 point. This CD is fine, but the problem is that it's way too far away from the capacitor. How did that happen? It shouldn't happen, because in the symbols file, I have given you a capacitor with 2 labels on top and on bottom, right? I've given you something like this. So you should be able to copy it over and change 1 to D, right? That's all. And that spacing is properly chosen in the symbols file. So this shouldn't happen, okay? All right. Let's see. Remember I said don't use the long dashed line, use the short dashed line. This is the short dashed line. It looks better than the long dashed line. Anytime you draw waveforms in the time domain, you do need to draw the time axis with T on it, okay? So if you don't draw this, it doesn't look professional. People would know what it is, but you do need to draw a timeline, time axis. This 0 in this diagram is italicized. It should not be italic. It should be regular, or what we call Roman. Why? Because 0 is a number, it's not a mathematical quantity. It doesn't represent a mathematical quantity. So this 0 should be what we call Roman. Roman means plain or regular or not italic. Okay. You see Vx and Vy here? They're too far from their respective waveforms. So the way I would do it is I would put Vx here and I put Vy here. Something like that. So that the eye can easily follow it. This also goes to when you create plots. Let's see, we had a plot maybe back here. When you have plot of multiple, so here. No, not this one, okay. So, let's see. Plots that have a better behavior, not a scatter plot, but something like this. Now, I'm not saying that we should do it for this plot because it's way too crowded. But imagine that you had, for example, 3 plots only, okay? So if you had 3 plots, then it's better to put the legend on the plots rather than on the side, because the eye doesn't have to travel back and forth between the legend and the lines. So if you had only 3 lines, so let's say the green is, I don't know, HT, so you would just write, in MATLAB, you would write HT here, okay? And then this one is, I don't know, DDR, so you would write DDR here. So the eye knows. There's no need for a legend out here, okay? Now this is too crowded, so we can't really do it for this one, but if you have only a few plots, you can do that. Okay, let's move on to... Any questions so far? Okay, let's see. So we talked about this mux here. This is another one. So here we do need a time axis. Okay. Also, you should always ask yourself, when I draw a timing diagram, this happens all the time, okay? People like to draw timing diagrams that are really complicated. You should ask yourself, can the audience possibly understand this timing diagram in the limited time that I have for this slide? Right? The answer is probably no. So if they're not going to understand, why do you make it so complicated? So In a formal presentation, again, you'll spend probably 2 minutes on the slide or even less. So then what you should do is you just figure out the bare minimum necessary to impart the message to the audience, right? So for example, you want to say there's a reset mode, a resolve mode, and a hold mode. So you just draw 5.3, 5.4, and D1 or something. You don't draw the rest of it, you don't draw the future periods, you just have something very simple. Also, if you really have to show more waveforms, then you should animate it, right? So you show, for example, 5.1, 5.2, 5.3, and say, okay, well, this happens, or this happens, and say, well, but actually I'm going to need 2 more phases, so I'm going to add 5.4 and D1 or whatever, right? So you should animate it. And again, here, these are times. They shouldn't be times. They should be Helvetica. Okay. Going back here. So here, this is D1. 1 is a subscript. But here is D01, and 01 is not a subscript. What happened here? Right? Doesn't make sense. So these inconsistencies should never happen in a formal presentation. Because if you're inconsistent about something like this, people will have less confidence in what you do. Right? If they say, okay, he or she's going to design this complicated chip, how do we know that there will be enough attention to details? Okay, when you have something like this, there's a problem, right? I guess the intention was to draw a dashed line from here to here, but the spacing was too short, so we ended up with 1 dash, right? That shouldn't happen. I don't know why this is happening here. Maybe because the line stopped here. You should stretch the line all the way to here, and then in that case you will see 2 or 3 dashes, not just 1 dash. Okay, so here's another diagram, 4 differential pairs acting as a mux, and this looks pretty good. Again, think about the spacing that I mentioned, okay? So is this spacing necessary? No, right? Because you don't have like M1 and M2, there's no label, so these can be pushed closer to each other. And then that means that all of these can be pushed closer to each other. Similarly, this spacing, is this spacing necessary? No, not that much. Is this spacing necessary between these 2 lines? No, you see, these 2 lines are so far from each other? No. So again, everything has to be compacted. When you compact these things, the result looks much nicer. One other thing that you should keep in mind is that psychologically, if a person looks at the slide, the largest objects in the slide bear the most amount of significance in them for the person. Okay? So whether you want it or not, that's how the person will perceive the picture. So if you draw something really small and you think you wanted that to be very important, well, that's not going to go through because people think if it's small, it doesn't matter. So always pay attention to that one as well. Okay. So generally, we don't do this up here for the supply, especially when these are drawn close to each other. We just have one solid line, which would stand for VDD, right? You don't have to go connect them and then go to VDD. As you will see, this spacing is a little too much. So less spacing here. I'm saying this because you will see at some point in your life, every millimeter of these matters in terms of squeezing a lot of information in one diagram. So these all matter. This line here. So I have a differential pair in that symbols file as an example. And you can see that I click in iDraw on near this arrow tip, and then I go straight, meaning that the line actually goes like this. It's not so far down. It's the first grid available below this arrow that allows you to make a right turn, left turn, right turn, and go this way and then come back up. So that saves you 1 grid spacing here. Okay, everything will be shifted up by 1. And again, every one of these matters eventually, as you will see later in your life. Okay, so again, you see there's so much spacing here for no reason, right? There's so much spacing here. Why? Well, I think I know why, because there were inverters here and you could remove the inverters and then keep the spacing, right? But there shouldn't be. Okay, so a few words about these things. First of all, the text should never run into the box. Okay, that's a big no-no. The text should be contained in the box. For example, like this is fine. Here, this R is almost touching or actually touching that edge. That shouldn't happen. Here, the text has become italic. It shouldn't be italic. This is just regular box labeling, so they shouldn't be italic. And here, we have this sort of acronym, CH-steering for charge steering. Well, that's not the way to abbreviate something, right? If you really want to abbreviate it, you would abbreviate it properly. So it's charge steering, it would be CS. But CS is too short. It can stand for so many things. So you might say charge steering logic, and then you would call it CSL, right? Just like CML, you have CML driver, you would have CSL mux, right? Something like that. But I would try to squeeze charge steering here. I would say charge steering mux, right? If you make an acronym, it will be effective only if you use it a lot in that presentation. If you use it only a few times, people won't remember, right? You said charge steering CSL way back there in some slide, and by the time you get here, they don't remember what CSL stands for, right? So you have to pay attention to these things. Okay, moving on. So, this circuit diagram is an example of poor drawing. So let's look at it. So as usual, out P and out N shouldn't be like that, right? It should be V out or D out or something, right? So if you want to look at more of a digital circuit, usually we call these Q and Q bar, right? And these would be D and D bar, not DZ. It should be D bar, okay? And then in terms of everything that I said before, this spacing has to be minimized, 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 right? Everything has to be squeezed. Now look at the dots. Here, you see these dots actually are not quite centered. I don't know what happened. Maybe the grid was off when Yikun was moving these dots to here. So you should keep the grid on. Again, watch that video very carefully. You should keep the grid on so that these dots are exactly where they're supposed to be. Look at this dot. Obviously, this dot is misaligned, right? It's gone up vertically. It shouldn't happen. So as long as you keep the grid on, life is much easier because you don't have to zoom in and zoom out. You don't have to try to align things. They align very nicely. And again, this should be just one line for VDD, and that would be much easier. If you have dots here, you need dots here. What happened to dots here, right? So you need dots here as well. Okay. All right. So again, you can see the text has to be bold, the spacing has to be less, all that stuff. You need a time axis here, etc. A lot of times when you're drawing a timing diagram, what you will see that it turns out to be too tall, and that's difficult for inclusion in everything. So what I do is actually I draw these waveforms shorter. Really, there's no reason for this waveform to be so tall. It can be half as tall and still fine because we don't really carry much information in that height. It's not like we're labeling it to be 250 millivolts or we want to show some noise on it or some distortion or anything. It's just a ones and zeros, right? So then it doesn't have to be that tall. So when this is this tall, each of these is half as tall, this whole thing will be approximately half as tall, so it fits in different places much more nicely. Okay, so those are things to keep in mind. All right, any other questions? Okay, so here's the same problem. Calibration is running into this line. So in fact, this N now looks like an R because part of the N is missing, right? So that shouldn't happen. The text has to be not italic. It should be Roman, all that stuff. Parallel inputs, series outputs. If it's outputs, it needs a line here. By the way, this line should be the other way. So it should be this way, not that way. If you want to indicate multiple logical lines coming in, it should be that way, not the other way. Okay. And again, all the spacings, everything else as we said before. Okay, so let me go to the other presentation of Yikun's, which is this one. So this is similar. There are some changes I wanted to show you, so we will skip some of these. Okay, so here you can see that Yukon took those previous drawings and made them much more compact, right? So now we have text flowing vertically, and the boxes are closer to each other, they're more compact. So when we come to iDraw, to PowerPoint, and enlarge it, the proportions look much nicer. So here we have the same situation, and so on. But these also need proper, as I mentioned before, all the things that I said here. Okay, now about plots. I mentioned a bunch of things before in terms of making the fonts bold and legible and large, and the legend, etc. So here, for example, because you have only two plots, you don't need to say MSB, LSB here, right? MSB would be like on top of this guy, LSB would be on this guy. In fact, if you want to make it even more legible, I would draw like one of them in red, one of them in blue, and then the red one would have a red label and the blue one would have a blue label. So then it's very easily visible, right? The labels would be on the waveforms themselves. But there are other things that you have to care about. For example, look at the resolution of this axis. Is what we see is 0.5 volts and 1 volt. What happened? What happened to all the numbers in the middle? The resolution is so coarse. This is not a professional plot, right? You should have like 100 millivolts ticks here or something, right? So that means that I think this is what MATLAB does sometimes. So you have to be careful about how you shrink a plot, right? When you in MATLAB you go and you grab the frame and you want to shrink it, it automatically wants to set these things, and then it doesn't do a good job. So you need more ticks here so that it's clear what resolution we have. Also for the time. So let's say I see this plot for the first time, and I have only 10 seconds really to understand this plot because I have to pay attention to the rest of the slide, right? So now how do I read this? 0.5 what? Okay, 0.5 times 10 to the minus 10. Okay, now let me do the calculation what that means. Is that 0.5 nanosecond? No, that's not 0.5 nanosecond. Oh, it's 50 picoseconds. Okay? So it took me more than 10 seconds to figure out just the unit here, right? So it shouldn't be like that. So what you do is, again, you have to play in MATLAB to get this right. So yeah, this would be, for example, if this is 50 picoseconds, you say 0, 50, 100, 150, 200. You don't have this anymore, and this would be picoseconds. Right? That's the way to do it. Not like this. Never do this because it's very hard for people to figure this out in real time. Okay? They're not stupid, but it takes time to understand what's going on. Okay, same with this plot. Okay, I diagram, for those of you who are working the time domain, I diagram should be two words, not one word, and there's a space between them, and if you want to capitalize, both of them are capitalized. Okay. All right. So again, if you look at this CP1, this C is shifted up too much. It shouldn't be. Again, if you copy the capacitor and it's labeled directly from iDraw, the spacing is preserved. You don't have to worry about it. Okay, but this C is far too high. This VB2 is running to this dot. Again, it needs fixing, and all of that stuff I mentioned before. Also, in cases like this, it's good to have some sort of bullet here because it's not clear what these, I guess these mean like disadvantages or something, but it's hard to see. So it's better to have bullets. Sometimes what I do is I use one color to show advantages, one color to show disadvantages. That's more visible than trying to show with crosses or positive or negative or something like that. So do use bullets, not these types of things. Okay, so we discussed these before. So again, these things are not legible. So in a formal presentation, we don't want to do this, right? So for example, I can take this whole thing, rotate it by 90 degrees and put it over here. And then I draw two dashed lines. So it would be something like this, two red dashed lines from here to here. And then actually I put the arrow here, not inside the eye. And then I say, I don't even need to say BPP differential, I just say 650 millivolts, right? So that's much more visible than this crowded lettering on top of the diagram itself. Again, these fonts have to be bold. Now this is good, it says picoseconds, right? So that's good. But T in time has to be capitalized, right? Now here it says V millivolts. It's okay because V means voltage, and usually we would like to label it properly, but this is obvious enough that it's okay, we don't mind. More properly, we would say amplitude instead of V. Okay, so this plot was produced by MATLAB, I presume, and for some reason, when I look at it on my screen, I see that the resolution is pretty poor. Here it looks okay, but on the screen on the computer looks pretty bad. I'm not sure how you guys bring MATLAB plots into PowerPoint. So generally, the way I do this is that I take a MATLAB plot as a PostScript file from MATLAB, and then I convert that PostScript file to a PDF file using proper conversion. So the best PDF converter I know is actually on my own machine. So you guys need to log in to Meteor, and Atharoff recently tried to do that. I don't know if it was successful or not. So Meteor, and then use this command distilled. Say distill, and then the file name, the PostScript file name. And then it says, it gives you three options. It's 1, 2, 3. You just click on 3, and then it converts it to PDF. It's a very robust, it's a Unix tool. It's very robust, and it does a good job. There's no loss in resolution, everything else. So for PDF conversion, that's the best way to do it, but there might be other ways too. So we don't want to lose resolution when we convert from PostScript to PDF, okay? Similarly with for iDraw files, if we need them to bring them in here. Okay, moving on, let's see. So here are some waveforms. So again, depending on the objectives of the presentation, we have to ask ourselves, will people be able to follow what we are showing on the screen in a limited time? So again, if it's an informal presentation, I guess the difference between a formal presentation and the informal presentation is that in the former, people don't ask questions during the presentation, like in a conference, right? But in the latter, people can ask questions during the presentation, like when you guys talk to TI or some other company, etc., right? So that's the difference. In a formal presentation, they have to digest all of this in 1 or 2 minutes. And the question is, will they be able to do that, right? These things are hard to follow. If you really want to show everything, you probably have to animate it, right? So you show it piece by piece. Okay, I'm going to start with the charge stereo multiplexer outputs. Here are the waveforms. It's very easy. You see that we have reset phase here, evaluation phase here, okay? Again, with proper font size, not 10 to the 8, all that, right? And then you say, okay, now let's see what happens to this waveform when it goes to such and such stage. Then you show this one, and then you show that one, and so on. Okay, so these are similar to what we had before. Again, you see how tall this structure has become. So these can be shorter, right? They don't have to be this tall because they don't carry information in their voltage. This one here, I have a beautiful NOR gate in the symbols file. So you should be using that one, not this one, right? Okay. So same problem here, the font is too small, not bold, etc. So here these should not be this, again Q or Q bar or something. That's the way to do it. For a flip-flop, I think I also have these in the symbols file. If I don't, you can send me email. I can send you some files that have these things in them for flip-flops, etc. So you can use those properly. And these are the things that we studied before. Okay. So generally, we don't want to write on the plot because it makes the plot too crowded.